Match each metamorphic rock with its parent rock. I have a few pictures down here. We have granite right here. Whenever you have granite is under heat and pressure, the minerals in there start to align in these nice foliated bands. This is called gneiss, G-N-E-I-S-S. So granite becomes gneiss whenever you, here's another gneiss over here, just a slightly different color, but you see the same foliation banding in there. So granite becomes gneiss. We've got shale and slate. I'll tell you, don't get those two mixed up. Shale is the sedimentary version of it, and we see as the mud gets laid down, it forms a sedimentary rock, but it's very brittle. It falls apart very easily. The piece I have in my class, it used to be the size like the limestone I have in there, very big. All right, but over the years, it just falls apart and crumbles very easily. However, when you apply heat and pressure to it, that shale becomes very solid. It's still got the nice foliation bands in there that we see in the shale. There's the flat lines where those mud laminations were at. But this is much more rugged. Slate is. It's very hard rock. In fact, that's what you make your countertops or tabletops in the science room. The blackboards are made out of slate. It doesn't crumble like the shale does. So shale becomes slate. We also have limestone. Is this chalk? In fact, that's what chalk comes from. It's from calcium carbonate. Fairly brittle material. Calcium carbonate. It dissolves very easily in acid. Apply some heat and pressure to it, and it becomes marble, like the marble statues that we see in European and Greece. So the limestone, this white material, it's also the same stuff they put on baseball fields when they line the field. It's a powdered version of limestone, the chalk that they put down. But under metamorphic processes, heat and pressure, it becomes this nice material that they can carve and get very detailed with it doesn't crumble apart like limestone does. Basalt becomes greenstone. We got a lot of this here in the state of Virginia. Basalt, of course, is oceanic rock. And this is a low-grade metamorphic rock. You add a little bit of heat and pressure. Chlorite starts to emerge, or gets squeezed out, I call it, of the chemistry. And chlorite is a green mineral, and that's what gives it this greenish color. And then finally, sandstone and quartzite. Of course, sand is quartz, and so sandstone, when you feel it, feels like sandpaper. However, when you add a little bit of heat and pressure to it, it squeezes those sand grains together, and it forms a much smoother material they call quartzite. We have a lot of this in the state of Virginia as well. In fact, we don't have very much sandstone. We've been hit so many times in the past with Pangea and other supercontinents. We've been right at the ground zero, per se. And what I have a rock in my class I call sandstone all year. It actually is quartzite, because sandstone is actually relatively hard to find in the state of Virginia. Most of it is a low-grade metamorphic version of it that we call quartzite.